And so what we're going to be looking at is the graph, the picture of ax squared plus bx plus c. The graph of y equals ax squared plus bx plus c is called a parabola. The graph is called a parabola. And they always look the same. They are a U-shaped graph that opens up, or they are a U-shaped graph that opens down. Our world is filled with parabolas. Lots of it come in. If an 8 o'clock hour, we have lights that hang from the ceiling. But if you were to look at the edge of the light, it's got a little bowl, and the bowl is shaped like a parabola, because that's how things reflect well. Here we've got recessed lighting, and you don't have quite the same thing going on. And if you were to take a look at solar collectors, the old first solar collectors that sat on roofs were if you look at them, they were kind of bowl-shaped like a trough, and the side of it looked like a parabola. U-shaped graph that opened up. Again, has to do with the reflecting qualities of a shape like this. And of course, we can't go past the McDonald's. They're double parabolas. If you take a look at the Golden Arches, parabola, parabola. There's just not only an M, but they're two parabolas on top of it all. So you'll find parabolas all over the place if you just look. Now, there are parts to the parabola. The first part we're going to look at is this point right here. And this point, which is a low point or a high point, this is called the vertex. And I label it as x sub v, comma, y sub v. V for vertex. V for vertex. There is a line that goes down the middle of the parabola. In college algebra, we called it a fold line. If I were to fold the parabola in half, half the parabola would be on one side of the line, half of the parabola would be on the other side of the line. And this line is called the axis of symmetry. The axis of symmetry. And it's an x value. Since it goes down through the vertex, it's x equal the x coordinate of the vertex. Because the vertex is in the middle of the parabola, so the axis of symmetry goes down through the vertex. Now, if I were to take a look as to how this guy operates, this he opens up. So if I were to take a look at the vertex is a coordinate point. This is a minimum. It's as low as it goes. And the minimum, as low as it goes, is the y coordinate of the vertex. And since the parabola here opens down, this vertex point is a maximum. And again, how high does it get? Its maximum height is the y coordinate of the vertex. So the vertex serves a tremendous purpose when you're dealing with parabolas. A parabola opens up if the coefficient of x squared, or a, is positive. So it's going to open up, which means it has a minimum. A minimum. A parabola opens down if the coefficient of x squared, or a, is negative. So it looks like this, which means it has a maximum Well, what about the domain of the range? Well, if y equals ax squared plus bx plus c, that's your basic parabola, this guy has no denominator. No radical. No denominator, no radical. So the domain is all real numbers. Well, what about the range? Well, the range, you have to look at the two parabolas. If the parabola opens up, the range, remember, are y values. It will start at the y coordinate of the vertex and go to infinity. So the range would be the y coordinate of the vertex to infinity. And then if it opens down, then you're going to start at minus infinity, and then it's going to go, there's the vertex right there, to the y coordinate of the vertex. So it's going to be minus infinity to the y coordinate of the vertex. These guys are very, 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 very predictable. They always look the same. They may be wider, they may be narrower, they'll either open up or they'll open down. They always behave the same.